Today's presentation introduces Resonance, an AI-powered consensus discovery platform that runs entirely on device. To begin, we identify a critical challenge in collective decision-making. Current consensus mechanisms do not scale effectively. Traditional voting systems produce binary outcomes, often resulting in exclusion and polarization. Deliberative models, while more inclusive, are typically slow and impractical at scale. Meanwhile, online discussions tend to fragment, reinforcing echo chambers and limiting genuine engagement across different perspectives. In contrast to these limitations, recent advances in edge AI have created new possibilities. Local models, such as Gemma, now support complex natural language processing tasks, including semantic understanding, sentiment detection, and control generation, entirely on device. Crucially, these models operate without transmitting user data externally, thereby preserving privacy and autonomy. Resonance is designed to harness these local AI capabilities to enable fast, secure, and structured consensus formation, all without requiring network connectivity or centralized infrastructure. Resonance is grounded in three foundational principles, which together define its architecture and intended impact. Resonance functions independently of any server or cloud service. All processing occurs locally, enabling full data sovereignty and resilience across diverse deployment environments. Rather than automating decisions, Resonance supports nuanced dialogue. It facilitates the emergence of shared meaning and agreement by bridging perspectives, particularly in settings where open communication may otherwise break down. By leveraging on-device inference, Resonance achieves real-time responsiveness, enabling interactive feedback cycles that support deliberation without delay. Together, these principles establish a foundation for a privacy-preserving, scalable, and human-aligned consensus mechanism that is deployable in fully offline contexts. Resonance is built from the ground up to bring intelligence to the edge, right where people interact, where context lives, and where trust matters most. We designed the system to operate offline by default. That means everything works out of the box, even without connectivity. When a network is available, Resonance can make use of it, but it never depends on it. The experience remains fast, secure, and consistent no matter where it runs. Rather than relying on centralized servers, the system is fully decentralized. Each device makes decisions locally and communicates peer-to-peer. This allows collaboration to emerge naturally across groups, without needing a central coordinator or exposing data to external systems. And privacy isn't an added layer, it's baked into the foundation. All processing happens directly on the device. No user input is uploaded, nothing is stored in the cloud. This isn't just about compliance. It's about enabling real trust in environments where people need to speak, reason, and build consensus without fear of surveillance or loss of control. This architecture gives Resonance its core qualities: autonomy, resilience, and privacy, all made possible by real-time, on-device intelligence. On top of this architecture, we've built a set of capabilities that make true local consensus building not only possible, but practical. All AI tasks, from understanding natural language to detecting sentiment and synthesizing group responses, are handled entirely on device. This ensures fast performance and full data control without relying on cloud APIs or backend systems. Devices connect directly to each other using a peer-to-peer mesh. There's no central server, no infrastructure dependency. This makes the system naturally scalable and fault-tolerant, whether it's running across 5 people or 50, even in environments without internet access. Instead of just collecting votes or tallying preferences, Resonance uses intelligent aggregation. It clusters perspectives, finds overlap, and generates shared summaries that reflect the deeper structure of a group's thinking. The goal isn't just consensus, it's meaningful consensus that captures nuance and common ground. And because the entire system runs offline, it works wherever it's needed. That could be a rural community forum, an emergency field deployment, or a network-constrained workplace. The full experience remains intact, private, fast, and reliable, with no connectivity required. This combination of local AI, peer-to-peer collaboration, and offline resilience defines what makes Resonance different. It's consensus infrastructure without the infrastructure. At the core of Resonance is Gemma 3N, our local large language model, not just used for generation, but as an engine for semantic understanding, abstraction, and emotional reasoning. What makes Gemma powerful in this context is its ability to preserve nuance while ensuring full privacy, all on device. One of its key capabilities is expression obfuscation. This allows the system to preserve the meaning of a message while removing identifying information, enabling local privacy processing that's difficult to reverse engineer. The core semantics remain, but the trace to the original speaker is gone. Gemma also supports multimodal semantic conversion. This means it can take images or audio, like a voice note or a symbolic photo, and translate them into abstract, language-based meaning. While this requires fine-tuning, it makes it possible to bring diverse input types into a common reasoning layer. Another standout feature is bridge language generation. This is where Gemma truly shines. When two perspectives appear to be in conflict, it generates language that builds empathetic connections, not by averaging the views, but by surfacing the emotional and value-based common ground underneath. This bridging ability is extremely hard to replicate and lies at the heart of Resonance's consensus-building power. Gemma also enables semantic abstraction. It lifts raw input into a higher-level conceptual space, turning specific grievances or personal stories into shared themes and abstract insights. This is what allows us to move from fragmented opinions to meaningful synthesis. Finally, emotional value analysis adds another layer. Gemma can map multidimensional emotional signals within a submission: frustration, hope, disillusionment, care, and contextualize them. This makes the system emotionally aware, helping it respond not only to what was said, but to what was felt. These capabilities come together to make Gemma more than just a local model. It becomes a bridge builder, an interpreter, and a guide towards shared understanding. Let's take a look at how this works in practice, starting with two real-world scenarios. In the first scenario, we focus on intergenerational emotional bridging. The elder participant submits, "I don't understand why young people today are always angry." The youth submits, "I'm just tired of pretending this world is fair." The system generates a bridge message. We've all experienced moments of being misunderstood, whether due to generational changes or personal experiences. That anger from being misinterpreted is real. Perhaps we can find common ground in our respective experiences. This output doesn't choose sides. Instead, it identifies the emotional thread connecting both, the feeling of being misjudged, and uses that to build understanding. In the second scenario, we look at value difference reconciliation. One viewpoint says, personal freedom is paramount. Another says, collective interest takes priority. Gemma responds with, "We all hope to live in a society that both protects individual choices and maintains common welfare." This balance, though difficult, represents the direction of human civilization's progress. Again, we see the system's ability to elevate the conversation, pointing toward a shared aspiration, even in the face of ideological difference. These examples highlight not just language generation, but deep value modeling, extracting and aligning emotional intent, even when surface-level phrasing suggests opposition. These capabilities open the door to a wide range of real-world applications, especially in settings where dialogue and understanding are essential but difficult. In education, Resonance can power platforms where students, parents, and teachers submit thoughts anonymously, with the AI bridging gaps and helping groups move towards shared values and policy decisions. In corporate culture building, anonymous feedback from employees can be processed to surface emotional patterns and generate constructive, aggregated suggestions, improving workplace trust without exposing individual voices. In community governance, residents can submit concerns or frustrations without attribution. The system identifies shared pain points, organizes them semantically, and helps local leaders move toward actionable consensus. And in social issue research, residents can collect honest, nuanced perspectives from diverse groups on contentious topics, then generate bridges that show where empathy and understanding already exist, even across divides. Across all these settings, the common thread is this: resonance doesn't just collect input, it transforms it into connection. Through local intelligence, emotional reasoning, and ethical design, it becomes a system that not only hears, but helps us understand. Looking ahead, we plan roadmap to expand Resonance's capabilities and reach. In the near term, we're focused on making interactions richer and more intuitive. This includes adding multimodal understanding, so the platform won't just process text, but also analyze images semantically and recognize emotions and voice. We're also working to upgrade real-time collaboration features, bringing support for immersive environments like VR and AR, so conversations can feel more natural and connected. At the same time, intelligent recommendations will start to personalize the experience, suggesting bridge language tailored to individuals to help foster understanding. Moving into the midterm, our vision expands to embracing global diversity. We plan to add full cross-language support, enabling users to bridge cultural and linguistic divides with multilingual consensus building and nuanced cultural difference analysis. Alongside this, we will build out a community ecosystem, a space where users can co-create content, provide feedback, and evaluate outcomes together, strengthening the shared ownership of the platform. Looking further ahead, we see Resonance evolving into an even more intelligent and adaptive system. We aim to develop advanced AI capabilities that can generate more sophisticated bridges between viewpoints and even predict how consensus might shift in the future. At the same time, we plan a global deployment strategy that accounts for cultural adaptation, ensuring Resonance feels relevant and respectful in diverse regions around the world. We recognize the urgent need for tools that rise above the noise and polarization that dominate today's discourse, enabling genuine consensus to emerge in an increasingly complex and fragmented world. Resonance harnessed the latest advances in AI to deepen human understanding, bridge divides, and cultivate a more inclusive form of collective intelligence. Resonance pushes the boundaries of what's possible with local AI. By running large language models entirely on device, we demonstrate a new level of privacy protection, showing that sensitive conversations can be handled securely without sending data to the cloud. We also explore semantic bridging technologies that allow the system to identify deeper connections between viewpoints that may initially seem opposed, opening the door for AI to play a meaningful role in conflict mediation. Beyond that, we transform abstract concepts of consensus into tangible visualizations that make collective wisdom visible and easier for groups to grasp. These visual forms help communities to see patterns in their thinking and understand how individual voices come together to form shared understanding. From a social perspective, Resonance works to resist information bubbles by providing bridges that foster mutual understanding in divided societies. It protects vulnerable voices through anonymization, allowing people to express genuine opinions without fear. And it contributes to building collective memory by creating a digital heritage of human consensus that can be passed down across generations. Culturally, Resonance aspires to more than just technology. It integrates deeply with humanities by creating digital monuments that stand as testaments to human collaboration. It fosters cross-generational dialogue by connecting wisdom from different eras. And it elevates data visualization into artistic expressions through consensus art installations that celebrate the beauty of collective decision-making.